Welcome back to the Little Blinking Light podcast. I'm Richard Pyatt. We're here with Roger Furwarn with AE Tech Design. And, you know, if you've been following us a little bit, we've been talking about some of the things that folks are fixated on as it relates to their technology, really important things. And we're going to continue on that path. Structured cabling is our discussion this time. So I come from radio. When I think of cables, I think of cords on the floor and coiled up behind equipment and things like that. They call it structured for a reason. It is a little more structured than that, isn't it?
Well, that's what we're hoping. We're really hoping that you have true structured cabling, not the rat's nest that we sometimes find.
That's what it was.
Which is all too common in our industry. And we're going to talk a little bit about why that's not good, not just from the aesthetics of it, but why that actually presents real legitimate problems to organizations for their infrastructure.
Sure. And when we talk about structured cabling, we really mean what's in the walls.
Yes, absolutely. No, we're talking about everything that goes from the jacks in wall up through the walls, through the ceiling, and into some sort of closet or wherever you may have your technology infrastructure, that hopefully a rack or some sort of secure mounting, and we'll talk a little bit about that too, and how that's not always very secure and why that can present challenges on many, many levels.
This has changed over the last several years, hasn't it? I mean, we used to just have our modular phone jack in the wall or something. This is much different.
Yes, and as more and more and more is relying on the network, and we're talking now buildings that have their HVAC running on their network, lighting controls on the network, a lot of automation, security, access control for doors. So much is being integrated into the network, and for good reason. You can't afford to have it be all culminate in a room or wherever it may go that is just a spaghetti mess of chaos. And for our viewers along the way, we're going to show some photos that you're going to be able to see. And for those that are just listening to the audio, Rich is going to put those in the show notes so that you can actually get a visual of what we're talking about. We have some before and after photos. We just have some photos of chaos that we've either seen ourselves or others have shown us along the way. And we'll talk about why those present different challenges to organizations and why they need to tackle those and plan for those. It's oftentimes one of those things where people don't realize it's not inexpensive to do, but there's good reason to do it. But more importantly, you got to be able to get everybody on board that's signing the checks for that. And if they don't understand the why, they're going to go, well, that just sounds like it's going to look nice. Well, no, that's not really the goal. But it's a real thing.
Well, it would be nice if it looked nice too, I suppose. You probably have encountered clients where it is a spaghetti mess full of dust and you have to untangle all of that.
Oh, absolutely. No, I've been a network engineer for many years and have come across many chaotic, ugly balls of chaos. And, one of the things that people don't realize is, everybody wants the network to work flawlessly. The internet's got to be up, all of the resources need to be up. And when things go down, people start yelling, hey, we got to get this up. It's costing our business. It's costing our organization money. How are we going to do that? And for the poor IT souls that are in those closets trying to decipher which end is what, that can be really challenging. Or sometimes the problems are caused by the spaghetti mess because somebody thinks they're unplugging one cable and they're accidentally unplugging another one. Or I've seen them so bad that people are stepping on cables.
Yes.
And you start tripping or you can take out an entire network by just accidentally stepping on the wrong cable. And those are all things that need to be addressed from a safety standpoint, but also from a functionality standpoint of the network.
Well, that makes plenty of sense. I mean, even if those of us who aren't inclined to understand all of these things, just, think about how you got behind your television and tried to deal with all of those cords. And that's hardly anything compared to what we're talking about. So I presume that, as we alluded a moment ago, this has changed a lot. And what needs to be available in a socket in the wall is a lot more than it used to be.
Yes. And, really one of the things that's nice is, for a while there in the tech world, and it's still true today, but less and less so, you had a lot of different kinds of cable. You may have coax, whether that's for some sort of audio video distribution cable. So you had coax, you had phone lines, then you had network drops, then you may have speaker cable. You had all of these different types of dissimilar cabling, and they all went to different places and they all did different purposes. And now what we're seeing is the convergence onto the actual network. Everything is a network drop. And as we'll show you, it's simplified things. It's made it so that in some ways, visually, it looks simpler. Everything can connect into the network. On the back end, it actually takes more administration. You're sending all of this stuff to different places.
Right.
And so there is actually some complexity that isn't visual. It's a virtual complexity that starts to happen in the network. But it makes it so that you have kind of one infrastructure that you're maintaining, not all of these dissimilar infrastructures, which has a lot of benefits. It allows it also that if you want to change what the purpose of a cable is, you don't have to change out the cable to make it happen, which is really nice. So as you make these significant investments in your cabling infrastructure in your buildings, whether you're renovating your building, whether you're building a new building, or whether you're just upgrading the infrastructure because it's 20 years old and doesn't serve its purpose well anymore, we now have it so that when you're making that investment into cabling systems, it's not just for the computer sitting on the desk. It could be for lights. It could be for all of those different systems. And now we are making an investment in cabling that's used for so many different things.
Boy, what's more complicated, updating a system that is in a current building or designing one and trying to anticipate what the future needs might be?
Well, even when we were doing existing buildings and doing upgrades to those, we're still trying to do that anticipatory step. So we're definitely trying to anticipate where the direction of data is going, and figuring out, for example, when do we use copper category 6 cabling and when do we use fiber optics? Fiber optics have withstood the test of time for being able to, be around for a very long time and not suffer from some of the setbacks of the speed limitations. Especially, we're big proponents of a kind of fiber optic called single mode fiber optics. And they have you could have, 40-year-old single mode fiber optics and they still work the same for the most part today as they did 40 years ago as far as that. But the amount of speed that you can get over them is tremendous. So there's some definite ideas around that we talk with our clients about. But just knowing when to use those two different systems, and where sometimes we may now be looking at using fiber as opposed to copper for types of systems is a big piece. It used to just be that if you had two tech closets that you're trying to connect them, you use fiber. Well, now there may be times where it makes sense that if you have, maybe you do video editing like we're going to do on this podcast, sure, you may want those workstations connected via fiber because it's not going to have some of the speed limitations over time that you're going to experience with a copper system. So
it's important to understand what the uses are.
It is absolutely really important to understand what those uses are and to understand. But to get back to your original question about what is it easier to do, it's always easier to design in a new building. Mm-hmm. And that's not just are we concerned about what kind of cable is in the wall, but we're concerned about the pathway. And is there pathway, or do we have to try to create pathway in sometimes buildings that aren't very conducive to it? I'll take it, for example, a lot of commercial buildings are built out of cinder block.
Yeah.
And so you have a cinder block building. It's very hard to get pathway through after the fact. So one of the things that we talk with our clients a lot about is, even if you can't afford all of the investment today, at least invest in the infrastructure of the pathway, because it will make it so much less expensive. And more importantly, it will look good in the end if you don't have all sorts of conduit running all over your wall trying to get cable from point A to point B. It's one of those things where infrastructure planning is really going to be critical for, okay, do we have the pathway? If we have the pathway, what does that look like going forward? And that way we're making those types of investments. It's the exact same thing as if you're going to pull one cable to a location, oftentimes it's it's not a big investment to go to two cables to that same location. Mm-hmm. All the labor really is almost tied up into pulling. It's easy to pull two cables to a location instead of just one. And so we talk a little bit about that too, and some of the advantages of why you may want to have two cables at a location versus just one, and why that investment makes sense now. So when we talk about new construction, it's easy because it's all done conceptually on paper. We're able to coordinate with other disciplines like electrical and plumbing and the architectural side to make sure all of these things line up. And then as it's being built, we can kind of adjust to anything that happens in the field. With existing construction, there's always a lot of unknowns. And there's always the things where we're saying, okay, we're going to save this system. Well, along comes the demolition crew and they start cutting cables left and right. And all of a sudden things are gone. And so we're able to adjust easily. And we've had that experience 100 times where, okay, now we're going to have to figure out, what do we do now? But we're happy to work on either type of system. It's really just one of those things where we have to think very differently about an existing building, some of the challenges of getting cable from point A to B, whereas with new construction, that really isn't a factor.
Boy, when you said cinder block, it made me think about the idea that you're often working in schools.
We are. Yeah.
That's a lot of cinder block, I would imagine.
Modern schools, or even older schools for that matter, they were built and rightly so with fire code in mind, and making sure that there isn't things that are going to catch on fire. And those schools are practically, besides the paper in the books, which are quickly being phased out anyway, there's not a lot of flammable things in a school anymore, which is really good, but it makes it really challenging sometimes to get those cables in.
But it can be done, I presume.
It can be done. Yes, absolutely.
Is there anything else that someone should ask their tech design firm when they're thinking about these kinds of things? Some basic things maybe that they should say, okay, firm A, here's what I think I need, or here's a challenge that you might encounter. What else should they be concerned about?
They really should be concerned about one of the things that we hear all too often from and oftentimes it's non-qualified firms that are trying to design technology. So we've come along, and actually I just came from a customer yesterday where their architectural firm had designed their cabling system, and literally the cables that came up into a heated closet. So you have all of this electronic equipment that's being overheated. That's a whole separate topic.
Right.
But the cabling they came up was too short to get to where it actually needed to land. So we actually had to add an entire system to kind of connect this cable that was too short and get it into a location that wasn't being artificially heated with then electrical components that were also causing heating and having this heating issue. But we had to fix, and it wound up being an expensive fix for a client who just had this brand new cabling run, and had it been done correctly and designed correctly, it wouldn't have been a problem. So as far as what people should be asking, they should be asking, what kind of standards are these being done to? In the cabling industry, there's an association or a company called BICSI. BICSI is an accreditation that installers and designers need to adhere to make sure that their systems are being set to a standard. It's done for safety reasons, but it's also done so that your system actually makes sense and will live and have a long, useful life. I worked in an environment where they had probably about 500 network locations that were coming into a closet, came into a couple of racks, and those racks, the cables were so tight you couldn't move the rack but maybe an inch in any one direction.
Oh my.
Well, then they had also happened to build an air conditioning unit above those racks. Well, the problem with air conditioning units is they condense water as part of what they do. Yeah. And so you have water that could, in theory, if a drain doesn't work properly, overflow on top of, hundreds of thousands of dollars in electronics. And we couldn't move the racks around to try to get it out from under there because the proper service loop was not installed with the racks. And because nobody followed Bixby. If it had been a Bixby design with Bixby installers, that wouldn't have been a problem. But in this case, you have a situation where these racks were just thrown in there. Nobody had coordinated with the mechanical engineer who had also placed an air conditioning unit over top of them. When I was thankful there was air conditioning and there was even redundant air conditioning in this very important room. But at the same time, if it starts spilling water all over the equipment, that's not going to be a good solution. So it's taking in all of these considerations and really making sure your designer isn't trying to shortcut the cost in the short term to then actually wind up costing you more later. Or, for example, nobody had checked that the installer was using the right cable. So 3/4 of the cable in that environment was to one standard, but a quarter of the cable, they ran out of the first cable. They just used cheaper, less performant cable. And in a cabling system that was installed like 3 years, 25% of their network cabling had to be redone at a much higher cost because it wasn't being done now at new construction time.
Right.
Because they didn't plan accordingly for that.
So the client should say, are you following a standard? They also might say, let's interact with all the parties involved.
Yes.
So everybody's communicating.
Well, absolutely. You want to make sure that they are, and that you have the right discipline working on that. We have firms that concentrate, for example, on electrical engineering. Some electrical engineering firms may have people that specialize in our kind of technology design, which we call low voltage. It's not the in-wall, I'm going to go plug in something to 120 volt AC outlet. This is the stuff that's being done on the network. It's being done in your audiovisual systems. It's a different kind of discipline. And because of that, most electrical engineers don't have that specialization. They know electrical really well, and they know many of the same concepts we do from an electrical standpoint. But when you start getting into best practices for our world versus their world, it becomes very different. So you want to make sure that you have the right discipline, designing the right things, and then coordinating with those other disciplines. And that coordination piece is so critical. And as the owner of a building, you need to make sure that those people are talking to each other, that you have parties that are working well together, and that you're holding them accountable, that your expectation is that they're going to do that. All too often, that doesn't happen.
Yeah. All right. Well, you wish to have these questions answered, have this coordination take place, and AE Tech Design is in the name, so they're prepared to help you with that, Roger and his team. So when it comes to structured cabling and this kind of interaction, it's important.
It is.
Reach out and ask questions about that. You and your team are ready to do so.
We are. And thank you so much, Richard, for this time.
Little Blinking Light, that's our podcast. We'll be back with more soon. Thank you.
Thank you.